Okay, we're going to do section 6.1 here. 6.1 deals with estimate and finite sums, and there's two parts to it. One's kind of doing it by hand, and then the other part is doing it with calculator. What we'll learn is the distance traveled, RAM. I don't know if we'll get to these too much in this section until we get to homework problems, but most of the video will be talking about these first two things. Let's look at a particle. I'm going to left everything out here just to see what so you can see the problem. A particle starts at x equals 0 and makes along the x-axis a velocity of t squared. So here's my curve. This was my velocity curve for t equals greater than 0. Where is the particle at t equals 3? Okay, so how far did it travel? If this is my velocity, how far did it travel when it gets to 3? So we graph the velocity and partition the time interval into sub-intervals of change of t. If we use change of t to be 1/4, we'll have 12 intervals, because 1/4, there's 4 intervals between each interval. 4 between 1, 4 between 2, 4 between 3. So we got 1/4, 1/2, 3/4, 1. 1 1/4, 1 1/2, 1 3/4, 2, and so on down the line. The area of each rectangle approximates the distance traveled over the subinterval. Adding all these areas of distance gives us approximation of the total area under the curve. Total distance traveled from t equals 0 to 3. So in other words, if we took area of all these little rectangles, add them up, we would have distance traveled, because the area underneath the velocity, the area of each rectangle approximates the distance traveled over the interval. So area underneath the velocity graph is the distance traveled. So if we start with the subinterval, 0 to 1/4, we're going to use midpoints. So between 0 and 1/4 is 1/8. The height, if you look back at the graph, the height, anytime on this graph, the height of my rectangle is going to be this curve, t squared. So therefore, if I take my height squared, t squared, 1/8 squared, midpoint squared with 1/64th, and times it by my width of my rectangle. So what you're looking at, if I drew my rectangle out, I'm going to go up to the midpoint. My height's going to be from here to here, which is the height of my curve. So it's going to be 1/8 squared on the first one, and my width is going to be 1/4. Now the 1/4 never changes on here. Notice the area never changes. So if we found the area of that first rectangle, it's going to be 1 over 256. Then from 1/2 to 1/4 to 1/2, using the midpoint, squaring it, times it by a fourth, we get the area there. Keep doing that all the ways along for all 12 intervals, and then add them up. Now, that will give us the distance traveled. Now, there's different distances out here, so if we add them all up, so you notice here we get first rectangle, second, third, fourth, and I'm going to erase this real quick here. And we add them all up. Here's all 12 rectangles. And we end up at 8.98. So approximately the distance traveled is 8.98. And I'll come back to that in a little bit, but this is just taking the midpoint rule. Midpoint. Now there's different ones we could do. There is different kinds of rams. There's LRAM, left ram. So where we could draw my rectangles up to the left side of this curve and add those rectangles up. Notice how the LRAM, we're going to be short because there's a little gap that we're missing on each one. So there's going to be a little bit less, not enough. There's MRAM. This is MRAM. And I call it middle ram, midpoints. Notice when we draw it up to the middle point, it might be a little bit too much in some areas, and a little bit, it loses some and gains some. They offset, but it's still probably off a little bit. And this is LRAM over here. And this is RRAM. Now RRAM, if we go to the right point and draw my rectangles. And so on the RRAM, you'll notice it's too much. Now it depends on the curve. Now if I drew a curve like this and drew my left ram, as I move along, might be less air. Where I drew my right ram might be more air, or it depends on how the curve looks. If the curve is going down here, I drew my left ram, it's too much now. So there's different ways where you have to understand when is the area going to be too much, when it's going to be too less, when it's going to be approximately right. Now we're going to say estimate the area of the graph of x squared from 0 to 3. Of x squared sine of x from 0 to 3. So what we're going to do on here is say, okay, let's just do an easy interval. If I set 0 to 3, I'm just going to set up half intervals. And then you use the program on your calculator, and we get the answer. So what we're going to say, let's say I set up this easy interval here. 0 to 3 here, my graph was going to look like something like this, let's say. I'm going to have a point at 1. I'm just going to do 1, 2, 3. I'm just going to set 3 intervals. 1, 2, 3. 0 to 1, 1 to 2, 2 to 3. Now, if I use right RAM, what do we know? Might be a little not enough, okay? So if I set up 3 intervals, my interval width, this is right RAM, my interval width is 1, and my height is going to be my curve at this point. Okay, so what we're really going to do here is to say, okay, we're going to go into our graph and say, area of the first rectangle is going to be 1 by, okay, my first point I'm going to plug in is 1. Plug in 1 of this equation, I'm going to get 1 squared is 1 sine of 1. Sine of 1. That's going to give me the area of that first rectangle. Plus, width of the second rectangle is 1 times. Now the point I'm going to plug in here is 2. 2 squared is 4. 4 sine of 4. Plus 1 times. The height here is 3. So it'll be 9 sine, well actually this is sine of 2, sorry. Sine of 3. Now if I add up these 3 areas, the area of the rectangle here, 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 that's going to give me the approximation of what the area is. Now I can do that in the calculator and get the answer. Now that's one way. Now if I wanted to, let's just draw that same curve again. Now let's go left RAM this time. I'm going to go up here. What I'm going to do is I'm going to say this is 1, this is 1/2. .5 and 2. I'm a little short in my values here, but 2.5, 3. Now what I did here is I made it into 6 intervals instead of 3 intervals. Now the more intervals you make, the better approximation it is. Now your intervals should be the same length. Now my picture doesn't make it look like they're the same length, but it's very close. Now what we do here is say, okay, on here is set up the same way, but instead of 1 times, our width of our rectangles are going to be 1/2. Now my first point, I'm using LRAM. My first point I'm going to plug in is 0. So I'm going to have 0 times, my equation was this, I'm going to put it over here, x squared sine of x. So if I plug in 0 in here, it's going to be 0. So 1/2 times 0, plus my width of my second rectangle is 1/2 times, I plug it in 1/2, so it'll be 1/4 sine of 1/2, plus my third rectangle, I plug it in 1, so it's going to be 1/2 sine of 1, plus, I'm going to move it down a little bit here, my fourth rectangle, I'm plugging in 1.5, so it's going to be 1/2, and I'm going to write it out, 1.5 squared sine of 1.5, plus, that's my fourth, the next rectangle I'm going to plug in 2, so it's 1/2, the width of a rectangle, times plug it in 2 in the equation, 2 squared sine of 2, plus, next one I'm plugging in is 2.5, it's 1/2, times 2.5 squared sine of 2.5. Now you notice I have 1, 2, 3, 4, 5, 6 rectangles. That's what I wanted. Now if I add that up, I'm going to get an answer. Both of these give me an answer. This is right RAM with 3 intervals. This is LRAM with 6 intervals. Which one's the better? The more intervals you have, the better the approximation is going to be. Now, in that saying that is, you're not going to sit here and do 1,000 intervals. It takes too long. So what I'm going to show you here is another way of doing it too. And I want you to know how to do it by hand too, because you're going to show me both methods. So I'm going to go on your calculator. If I get this to pop up here. Okay, here's my calculator. Now, what I'm going to do here is I'm going to first, you got a program. I'm going to go under Documents. Actually, I'm going to go up here, My Documents. I should have put a program into your library. Hopefully it's there. And I have to find it first here. Area. Okay, so here's my program. Now I'm just going to go over here and just start a new window. Once I open the program, it works okay. So I'm just going to go here and then go to calculator page. Now my program's open, and that's okay. Now how the program works is the first thing I need to do is define the function. And I'm going to define it like in graphing mode. So if I went here, I went down to graph. It was nice about this program, it lets you graph. And I'm going to graph, you have to put it into the F1. And I'm going to delete these. These come with the program, so I don't want those in there. So F1, I'm going to put in here what equation we work with. X squared sine of x. That was the formula we had a second ago. Enter. And we're looking at the graph. A graph looks like this. It goes from 0 to 3. This is the part of the graph we're looking at. We want to find the area underneath that. Okay? So now I'm going to go back to this. Now, the hardest thing in here is remember all the rules on this one, and I have to look back at the rules. So let's go back here. These are all the things you can do. RS left means RS left rem. RSM, RSR, SR, TR, RSA2. You know, you got a lot of different ones here. You know, and I looked at some of the formulas as you go through here and what they did. And I like the one I like is RSA. Okay, so I'm going to go back to my drawing and how this program works. Once you have the formula defined, that's all you have to type in is RSA. I'm having a hard time seeing my words. RSA. Notice when you type it in, it gives you the thing, parentheses, where you're going to end. So we're going to go from end at 3, comma. Oops, I got extra variable there. Start at 0, comma. Then how many intervals we want? Well, we did 6 intervals. Enter. Now, if I did 6 intervals, this does all of them for me. You notice that the left says 5.29, right says 5.926, midpoint, trapezoid rule. It gives you a lot of information. Okay, so now I say, okay, that doesn't, it's too far apart. 6 intervals must not be enough. So let's go back up. I'm just going to highlight this again, hit enter. But I'm not going to do 6 intervals this time. Let's do 100 intervals this time. Enter. Okay, 100 intervals took a little bit longer, but notice now, look at the values. Left is 5.75, right is 5.79. It's getting closer. They're almost all the same. So I'm guessing my values are going to be close to 5.7 something, 5.8. And I can go back and say, okay, well, that's getting pretty close. Let's do it one more time here. See what happens. I'm going to say, okay, let's do 500 intervals. Enter. So there's my value. Now look at this. My left is 5.77, 5.78, 5.776. So I'd say 5.77 is pretty close to my area from 0 to 3. This program is very nice. These are 2 other rules that we'll be covering later on. This kind of gets you started in looking at the different things. 3 is where you end, 0 is where you start. This is how many intervals. You have to work with that program. This kind of finishes off. Make sure you answer the essential questions of this section, and I will be adding those as we move along. Thank you.